folks, welcome back. We're gonna take a look at one of these quadratic inequalities, but this time we're gonna solve them algebraically. And we're gonna make something called a sign pattern. And you can think of a sign pattern as a smushed, this is not a technical term, smushed XY coordinate system. And what I mean by that is we're used to graphing things XY. Imagine if I smushed that, okay? If I smushed that so that we only care about the X values, only care about X values, and I'll say about specific X values. And I'll talk more about what I mean by that. And then you only care about the sign of your Y values. And when I say sign of your Y values, you have three options. You could either be positive, 0, or negative. All right, so we're gonna, instead of writing X and Y, we're gonna smush it down to just an X axis, all right, where we're gonna write specific X values along this sign pattern, and we're only gonna write positive zeros and negatives for the Y's. So here's what I mean. All right, so I could graph this, right? And we've done that previously in examples like this. If I wanted to, I could go ahead and graph this quadratic function, and I can say, where is x squared minus x minus 12 above or on the x-axis? So I could hit zoom 6 here, right? And we could say, hey, you know what? It's above the x-axis here and above the x-axis here, right? And I could write those intervals up just like we had been previously, but we're gonna do all of this algebraically. So the algebra starts in a similar pattern, all right? And what that means is you are still gonna look for x-intercepts. So when I wanna solve things like this, I am gonna take my quadratic expression of x squared minus x being 12, and I'm gonna set it equal to 0 and solve for x, okay? Now, you can, again, factor, quadratic formula, complete the square. I'm personally just gonna factor. So I'm gonna get x minus 4 times x plus 3 is 0. So I'm gonna learn that x is equal to 4 or negative 3. And I don't need to write those up as x-intercepts anymore because I'm not technically gonna graph. But what's gonna happen when I write my smushed sign pattern, my smushed xy coordinate system, right? Instead of x and y, right? I'm not gonna write both, I'm just gonna write the x-axis. These, when I say we care only about specific values of x, those are the specific values, okay? So let me go ahead and erase this. And let's go ahead and write our smushed xy axis, okay? So let me write a number line. And what I'm gonna do, I'm gonna write my horizontal x-axis, all right? And I'm gonna put x's below my smushed xy axis, and I'm gonna put y's above. So x's are gonna go below, y's are gonna go above, all right? So I could put the letter y here, but what I want us to try and focus on is putting the actual expression, the quadratic expression that you're creating a sign pattern about. So I'm gonna say x squared minus x minus 12, okay? X coordinates go below the x-axis, right? Those specific x values. Signs of y go above. All right, so you're gonna see a bunch of plus, minuses, and zeros up here. All right, so how we start this is I will move left to right. Negative 3 is the first x value I care about. 4 is the second x value. All right, so I put my x values here. All right, so how we would read this, when x is negative 3, x squared minus x minus 12 is 0. That's how we found this value, okay? When x is 4, right? If I'm looking at the bottom, when x is 4, what is the sign of x squared minus x minus 12? It is also 0, okay? And then we have to decide, do I put a plus or minus here, plus or minus here, plus or minus here? All right, there's some collection. It might go plus, 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 might go plus, minus, plus, might go minus, plus, minus, minus. It could be anything. We're gonna determine it. So how we start this, and this is your first wave, and I will eventually get to the faster way to do it, but here's the starter way. Pick a test point. So come up with any x value that's larger than 4. I'm gonna put 5 here, okay? I could have put 6, 7, 12, whatever you want. Plug this in to your original inequality, right? Or your original quadratic expression, right? I'm gonna plug it into x squared minus x minus 6, right? And you can do 5 squared minus 5 minus 12, but we ultimately just wanna keep track of when are things positive or negative. I don't care anymore about the specific y values, right? So if I plug in 5 squared is 25, 25 minus 5 is 20, 20 minus 12 is 8. Ultimately, that's a positive number, so I'm gonna put a plus sign here. I find it easier to put this into the factored form and keep track of pluses or minuses. So what I mean by that is if I plugged 5 into this first factor, 5 minus 4 is a positive number, 5 plus 3 is also a positive number, and a positive times a positive is positive, okay? And that's how I tend to do these. Once you've picked that test point, I erase because I don't like my number lines, my sign patterns to get crowded. Then I pick some x values, somewhere in between -3 and 4. And I'm gonna pick 0. I always pick 0s and 1s when I can, but let's plug 0 back into your original quadratic expression. And all I care about is, was it positive or negative? I don't care about the specific number of that y value. And again, I'm gonna plug it into my factored form, okay? So when I plug x being 0 in, all right, 0 minus 4 is negative, 0 plus 3 is positive, right? 0 minus 4 is -4, that's a negative number. 0 plus 3 is 3, that's a positive number. I only care about the signs. A negative times a positive is negative, okay? And then for me, like I said, I erased my little test point because I like to keep this nice and clean. All right, then let's pick something left of -3, like, I don't know, well, let's go with -7 right now, okay? I'm gonna plug this into my factored form. All right, so if I try -7 for x, -7 minus 4 is a negative number. -7 plus 3 is also a negative number. A negative times a negative is a positive. So that, and let me erase my little -7, that is my sign pattern, okay? And I wanna find where this inequality is greater than or equal to 0. So I wanna look for plus signs because that would mean where were you greater than 0, and I wanna look for zeros. I'm gonna collect that and then write it up. So I see a plus sign all through here, right? I see a 0, I wanna include that. I don't wanna include anything in here because it looks like I have a negative sign. I wanna include that 0 and that plus sign as well, right? And then if we start to write this up from left to right, we know we started at -infinity to -3, and then 4 to infinity, yeah? And that matches our graph, right? We've been doing this graphically and we can see that from -infinity to -3, your graph was above the x-axis, right? At -3, it was on the x-axis, and that's what I want where it's equal to 0, right? Then it was below, I don't want to include that. Then it was on at 4, I want to include that. And then it was above from 4 on up to infinity, and I want to include that. So a sign pattern is just smushing this, right? I keep the interesting point of -3 and 4, but I don't care about the graph so much as this was above, below, above, or my y values were positive, negative, positive. And then I use that sign pattern to go ahead and write up my answer. And for me personally, I find this much faster. So I tend to do the algebra version rather than the graph version, but both are totally fine. All right, thanks so much. Bye.